Hello, good evening. My name is Joe DeVault. I was on Team 4, and this is our presentation on Practicum on the CSI corporate website. The other members of my team include Blaze Graham, Patrick Lepard, Jim Rutherford, and of course myself. The presentation covers 4 topics: key stakeholder concerns, architectural influence cycle, along with functional and non-functional requirements, early critical design decisions, and we'll also showcase some of the structural elements of the architecture. Some of the key stakeholder concerns that we looked at was that the business had said that they wanted the website to be both a transactional as well as a marketing site. They wanted it to be flashy. They wanted it in 8 weeks. And some other concerns were that the business actually wasn't really focused on a website, but more focused on their business. And also they weren't that enthusiastic about offering up resources to help with the project. In terms of architectural influence cycle, and how our architecture we think will impact the business, the solid design principle based solution that we picked, this object oriented, modular, extensible solution, we think creates a platform that in the future will make creating enhancements or new solutions much more robust, and the time to market will be faster. We think in terms of a project context, because we're using an SOA approach to the solution, we think that changes the dynamic of the organization, changes the who's supporting what, because now they're offering services where before they weren't. And when we do testing and go live, that also it's an integrated solution now, so that changes some of the project context. In terms of business, we're creating a corporate website. It'll be easy to use, it'll be flashy, so we think that'll drive business. From a professional standpoint, we think building a robust platform based on modern coding practices and principles will lead to future successful projects, and it will also help with internal resource development. Some of the functional requirements that were in the practicum that I think everyone's read are the ability to register users so that they can log in. Some of these functionalities will be for customer service reps, for admins only. Down at the bottom are the common functions that are true for all the different business units, whether it's the home inspection or the flood group or the appraisal group. The ability to go in and request service or request a quote, the ability to order new service or add a service to the existing one, whether they order one item from home inspection or order something from credit and home inspection, they'll be able to do those. Those are the common functionalities of the application. Some of the specific behaviors of the different business units are in the appraisal. Since they have a VDB6 client-server app, we're going to work with them to create services based on SOAP. For the credit group that runs Java, we're going to create RESTful APIs. For the flood group that's using Windows mostly technology, we'll do WCF. And for home inspection, who doesn't actually have anything, we have some options. And for now, we're thinking we could always go services. But right now, since they have a database, we could create an ORM like in Hibernate or Microsoft Entity Framework and access the data in a relational model using ORM. The non-functional requirements, these are both requested by the business as well as supported or created by the new solution we're bringing in. For example, the business wants scalability. They want to do 300 orders out of the gate. They want to be unlimited growth. They want high availability, 24/7. The platform we're bringing in is definitely based on dependency injection, so there's a high level of testability, compatibility. We're using different languages in the environment. Some people are using VB, some are using Java. So one of the non-functional requirements is that we need to have cross-platform compatibility and interoperability, which we think is there. In terms of maintainability, we're writing the corporate website in VB, which we think goes hand in hand with the fact that most of our developers are junior VB developers. And extensibility is there in the framework, and performance and security are always there and will be covered as part of load testing and QA. Early critical decisions that were made were bringing in solid, which basically is using interfaces and separation of concern and dependency injection. Going hand in hand with that is using a decoupled layered approach. So those first 2 bullets kind of go together. Something else that we thought was interesting and compelling is if you write an application in ASP.NET, you have to use what's called system.web. Well, recently, or in the past year and a half, Microsoft has gotten away from that approach and is now using OWIN, which is an open standard, and their implementation that's called Katana. And that strips away a lot of things you don't need in system.web and lets you build your own middleware that does what system.web used to do, but it's much lighter, much more scalable. So that's going to be part of our architecture. Again, the SOA is something we thought was important because we didn't want to rebuild the back end. We thought it just was the right thing to reuse those services. And finally, to get pieces of functionality out quickly. And also, we just feel there's no way we can pull off this project in 8 weeks. So our goal is to try to get out as much functionality, maybe 3 or 4 features in 8 weeks, and hopefully get funding to complete the rest of the effort. And if we don't, then they've got 3 or 4 or 5 pieces of solid functionality that are production ready. Because they wanted an application in 8 weeks, and the immediate response is, well, we can't build something in 8 weeks. We built a prototype for a couple reasons. One, to show them, yeah, you can build almost anything, in a day. This took like a half day to build, and it has login, and you can add a product to a cart, and you can persist it to a backend. And it's not hard to build those. There's lots of samples on the internet. You can build something, but it's not a production ready or scalable application. Over time, it's going to collapse on its own weight. So. And also, we wanted to be able to have a prototype to test out some of our ideas, since we're doing some things that they've never done before. This is a diagram of our business layer interfaces. Just shows the types of operations that you can expect to have in each domain layer. So the user service has things like get user, update user, authenticate user. Product service has a get product by ID. The order service has submit order and order history. And same thing with the cart, update cart, get cart. Very typical operations that you would expect to find in the business layer of an application. And similar with our data access. The reason I want to show this one, this is actually the product repository, which above that is the product service. So when the controller of the application calls the product service, it'll reach down and talk to this repository. And the repository has a couple of choices depending on the type of product it's dealing with. If it's dealing with a, say for example, home inspection, it's going to go the DB context route and use ORM. But if it needs to talk to flood or credit, it'll go the service gateway and either talk REST or API or WCF. This is a fairly busy diagram of the MVC app. The main points here at the very top right, you can see there's the views, the controllers, and the models. In the middle, you have a service layer. Below that, you have a data access layer. And then below that, you have a set of external services that are being consumed. One's a database service, and the other one is a web service gateway. And since we talked about the different services that were available at the data access and also the service layer, these are the models that get passed around. So in your service and your repository layer, you will have these business models, whereas at the lowest layer, when you retrieve it from the service gateway or from the database, those tend to be what are called DTOs, so they can be serialized and passed across boundaries. Conclusions and thoughts basically come down to building anything in 8 weeks is not going to be a production grade solution. It might work for 6 months, but eventually people will add on to it and will eventually collapse on its own weight. Prototypes are not designed to live forever. They're designed to show people how great things are, and then you go spend the money and you build something correct. The second conclusion is that building an SOA based architecture made sense to us because we wanted to reuse and not rebuild. Using Owen and Solid were good approaches because we thought it gave us a strong platform for this application and also for the future. And using iterative or agile allowed us to get high priority value out to the customer, get it into their hands so they could look at it, and just seemed like a good approach over doing a lot of work and then letting them see it. Finally, if there are any questions, my email is the last one on the list. There's Patrick's and Jim's, as well as Patrick's and Blaze's is there as well. So if you have any questions, don't hesitate to email us. That's my presentation. Thank you very much.